Alright, so we're going to pick up with this problem here that we introduced yesterday. And we're trying to find the cosine of the arctangent of 1 plus the arccosine of x. And we're not going to be able to find an exact value, but we will be able to get an expression for this in terms of x. Now, I set it up a little bit here for you. You'll notice our two angles, and these are angles because I have arc functions here. Arc functions return an angle when we use them. So here's cosine of u plus v. Alright, and cosine of u plus v is the cosine of u times the cosine of v minus the sine of u times the sine of v. Alright, so the first thing we need to identify here is what u and v actually are. Okay? In this case, u is the arctangent of 1. Alright, so what this is telling us is that u is the angle whose tangent equals 1. Okay? So what angle has a tangent equal to 1?
Pi over 4.
Pi over 4. Alright? So pi over 4 is our angle. So I already know when I'm plugging things in, I'm going to have the cosine of pi over 4 times whatever the cosine of v is, we'll get to that, minus the sine of pi over 4 times the sine of whatever v is. Yeah?
How do you know if it's pi over 4 or 6 pi? 5 pi over 4.
Okay.
And how do you know
How do we know if it's first or third quadrant? Because we're doing this as an expression,
Yeah.
when we use the arctangent, we'll go ahead and just use the range for arctangent, which went from negative pi over 2 to pi over 2.
Oh,
Okay? When you're dealing with an equation that you're solving, you need to consider all your possibilities. With this type of thing, we just need to do one of them.
Okay.
Yes?
So for like a test situation, if we were to have something to the effect of this, would you tell us that the tangent range is from negative pi over 2 to pi over 2?
Oh, for arctangent?
Yeah.
I might. So, or I might just tell you it's in the first quadrant or something like that. So. Okay, so now v. V is a little bit challenging. And the fact of the matter is we have no idea what v actually equals. However, we can find the cosine and the sine of v, even though we don't know what angle v is. Alright? So, you'll notice, first of all, I want the cosine of angle v. So I have the cosine of arccosine of x.
Is x.
It's x. Why?
Because it's inverse.
Yeah, these are inverse functions, right? They're inverse functions. So if I do the cosine of an arccosine, that's just going to, those are just going to undo each other. Alright? Does everyone understand that? Okay? So, I have what cosine is, so I can actually plug that in. Alright? But I still need the sine. Does anyone have an idea of how we could get sine? There's actually two ways.
Co-function or identities?
Identity, I wouldn't use the co-function, because that's going to give us the sine of pi over 2 minus v.
You could do it like a triangle.
We could do it like a triangle, that's one way. An identity is another way. Which identity do you think would be helpful here?
Sine squared.
There we go, the Pythagorean identity.
Yeah.
Sine squared x plus cosine squared x Right, I'm sorry, I should say V, because that's the angle we're actually using. Sine squared V plus cosine squared V equals 1. We want to know what the sine of V actually equals. So, solve for it. I'll subtract. But what is cosine squared?
X squared.
X squared. Cosine was x. We just said that.
So then sine is x squared minus.
Sine squared
So sine squared V is 1 minus x squared. There's our cosine squared. And then we square root. So the sine of V is the square root of 1 minus x squared.
Is it plus or minus or no?
We don't need, like we did with the pi over 4, we don't need to consider the plus or minus in this case. We're working with identities, not an equation to solve. So, alright, so we can plug that in. Sine of pi over 4 times the square root of 1 minus x squared. Now we have all 4 parts of our formula, and we can simplify. What is the cosine of pi over 4?
2 over 2.
Root 2.
Root 2 over 2. So we could write this as x root 2 over 2. Okay. Minus, what's sine of pi over 4?
Root 2 over 2.
Root 2 over 2. So we could write this as root 2 times the square root of 1 minus x squared
Now is that
over 2.
Is that the
2
same
minus
as,
2x squared, right?
the square root of 2 minus 2x squared?
Because they are both in radicals, we could actually multiply those together and make it 2 minus 2x squared. Another option that may make it a little bit simpler is you see a root 2 over 2 on both of those. So I could actually factor that out. See how I did that? I factored out the root 2 over 2 just to make it a little bit simpler. Honestly, I wouldn't be real picky about how far you simplified on this one, but you know, that might be the simplest we could probably go.
What if you left it in the one before?
That would be fine. Like I said, I wouldn't make an issue with that.
Can you explain how you got the x again?
How I got the x in the right here?
Yeah.
When we have angles and we have values from -1 to 1, right? So what we had originally, we had this one value, x, and the arc cosine of x took us over somewhere over here, okay? Because they're inverses of each other, if I were to take the cosine of whatever that arc cosine was, it'll take me right back to x. It's the nature of the inverse functions there. So, okay,
And then what did you do?
that's how we
To
got.
find sine.
That's how we got x.
But
Then I used the Pythagorean identity because I knew this was x. Well, x
squared.
squared.
So it's x squared v? Or just like
It's just the cosine of v is x, so a cosine squared would be x squared. Now, we also mentioned it's possible to do this with a triangle, and if this is helpful for you, go ahead. Once we know, actually I should put the arrow up here. Once we know that v is the arc cosine of x, that means, think of it kind of backwards, that means the cosine of v equals x, right? Cosine of this angle will equal x. Well, if we set up a little triangle then, where v is here, we could see x as x over 1. So the adjacent would be x, the hypotenuse would be 1. Right? Then we could use the Pythagorean theorem. 1 squared equals x squared plus whatever this is. Okay. We'll make it.
P.
We'll use b since that's part of our Pythagorean theorem.
X
Okay. So we would subtract the x squared, 1 minus x squared, and then we would square root. Again, we get 1 minus x squared. For this side, but then the sine of this would be that over 1. Okay?
Yeah.
So, any other questions? This is about as complicated as it's gonna get. All right, this is a kind of a complicated problem because it takes a deep understanding of what arc functions are, our identities, representing things in terms of expressions rather than concrete numbers. Obviously, you have to know your unit circle as a result. Okay, so there's a lot that you have to keep straight. A lot that you have to know here in order to solve it. Okay.
This reason? When is our test?
Tuesday.
Is the Wednesday?
So we're going to look at one more formula tomorrow. Again, you won't have to memorize it, but we'll look at one more formula tomorrow. So, all right, let's try one here, okay? So we're going to try one that will actually prove the cofunction identity. So I'm telling you it should end up equaling sine. Let's find the cosine of pi over 2 minus x using our formula here. We have the cosine of the difference of two angles. So what's angle u going to be? Pi over 2. And angle v is going to be x. Alright? So go ahead and try that one. Okay. Feel free to ask a friend for help.
Here.
negative sine of x? Does that matter? Or is
Yeah, you shouldn't. It should come down to just sine. Ahmet, you have this done? Well, then either ask me for help or ask a neighbor for help. Okay? Don't just sit there.
Oh, you did get it. Ah, I got it.
코사인 90도 90도 2.
Oh my god, I got it. You was
what'd you get?
sine of x. Okay, so the cosine of 2 is 0. And 0 times cosine of x is 0. 0 times anything is 0. And then sine of pi over 2 is 1. So sine of pi over 2 is 1. So it's 1 times the sine of x plus the sine of x.
Does someone want to put what they got up here? Alright, is
Actually, that works.
the tips are
Oh,
both
that's
low.
okay, it'll work,
Yeah,
okay.
unfortunately. Don't try to write like with the corner, the edge of it. Oh wait, hang on, sorry. There, I froze the screen. There we go, sorry.
Okay.
Okay, that's fine, I just wanted to make sure. Now, one thing, while she's doing that, I see you have a Samsung phone. There's actually a really cool app.
Are you getting it so much better?
There's an app. You can't use it for text, but the TI-84s.
Okay, so if that's a dumb word.
There's an app called Web,
No, it's top board.
Dumb word.
This one it looks just like
where you can actually run
So what about the
on your phone. That way, if you forget or if it takes you a little while to get your calculator from the store or something, you can. It's actually a really cool app. All right, let's take a look here. We plug in what we have for our formula. All right, and the key to this again is knowing your unit circle well. All right, cosine of pi over 2 is 0. The x-coordinate at pi over 2. Remember on our unit circle, pi over 2 is right here, so that's the point 0, 1. Okay. Cosine is your x-coordinate. I've had a number of times, especially doing this stuff, where people are forgetting that, cosine comes first and sine comes second. We're mixing them up a lot, all right? So be careful with your unit circle. Cosine was 0, so this entire portion equals 0. Sine of pi over 2 is 1. So we plug that in and we have 0 plus 1 sine, which equals sine. Okay? So, any questions about that? It's not too bad, right? Alright, good. Next. Let's try another one. We haven't done one with tangent yet. Okay? So let's try that. And just before we even get started, what's the period of tangent?
Negative.
Negative pi over 2 to the pi over
Hang on.
2.
You guys are thinking of the range of arctangent, negative pi over 2 to pi over 2. What's the period of the tangent function?
0
Zero.
to pi.
Zero
You're
to
still
pi.
thinking of a range, okay?
0 to
I mean,
pi.
But there's no range.
How often does tangent repeat?
Negative
That's the
1 to
period.
1.
Pi.
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 A period is not an interval, okay? A period is just a value, okay? So tangent, the period of tangent is pi. Keep that in mind as you do this one, okay?
Are we just doing B or?
Go ahead and do B right now. The period of tangent equals pi. Remember like last chapter we dealt with sine and cosine and sketching the graph?
Yeah.
And the period was 2 pi? Tangent's a little different, its period is only pi.
That's the period.
얘는 지금 슈도 큰 게. This X
Oh, yes.
is that
Right. No, it's not.
What does tangent of 3 pi equal? Oh wait, hang on. You still see right here? That should be tangent of u
Oh,
times
pi.
tangent of v. Yeah, that's right.
It's 1 0.
Oh, you just times.
No. Oh yeah, you're right. So it's pi, right? So it's pi plus tangent of 3 pi. What's that?
Is it 0? Look, you said it says 5, it says 2, but it says 3. So it's 0 again.
Can this be brought out like?
Sweet, that was.
No. Yeah, but think about the period.
Tangent of pi.
Tangent of 3 pi would be the same
the
as
tangent of 3
tangent
pi is
of.
0. Because it's like pi
Yeah.
is here, then it's 2 pi here,
Oh,
and then you go
what's
to
it,
3
pi
pi.
tangent
So
pi?
that's 0.
No,
Really?
tangent of 3 pi is
The
equal
tangent
the
of
same
0
as
plus the
tangent
tangent
of
of
1
0.
pi.
Oh, Isa.
Pi
Isa.
So what is that?
plus.
Theta.
Are you kidding me? Please.
Is that like
That's
this?
theta?
Sorry.
Oh, you can't cancel.
Oh, but we can still find out
There's
what
addition here, there's
Alright,
subtraction.
Yeah, that's the tangent of theta. Oh, that's nothing, right?
No,
That's
no,
like
it's-
not stupid.
That's multiplication right there.
Tangent
So it's 0 times tangent theta.
Oh, you want to
tangent theta.
Plus 0.
No, I know.
So it's tangent theta over
0,
1
but
minus
0 times 3 is 0. So
Oh,
0.
zero.
Oh.
Is it 0?
No, it's tangent theta.
Tangent
It's tangent
theta.
theta.
But that's, alright.
How could you?
Ah,
I
can't
know.
believe it.
You can have 0. I know, we got it on the bottom.
Oh.
Undefined.
No, it's 1 minus 2.
1. Oh, yeah.
Okay, let's take a look, see how you guys did. We're starting at 0. Here's 0. We rotate around to pi. Then we keep rotating. We're at 2 pi. Then we keep rotating and we're at 3 pi, right? So even just thinking in terms of coterminal angles, even if you don't remember the period of tangent, you know that 3 pi and pi are coterminal angles, right? So they have the same values for their trig functions. So that gets us into our unit circle. Tangent of 3 pi is going to be the same as tangent of just 1 pi. And what is that?
0.
It's 0. Okay? because it's the point, it's the point -1, 0. Sine is 0, cosine is -1. 0 over -1 is 0. So, this whole part right here equals 0. This right here equals 0. So in our numerator, we just have tangent of theta. And in our denominator, we have 1 minus 0. Which obviously is just 1. So that's tangent of theta. Okay?
I have a question. Why did you tell us to remember that the period was pi? That's the main thing.
Well, you could have actually even gone down to thinking, okay, tangent of 3 pi is going to be the same as tangent of 2 pi or 1 pi or even tangent of 0. Okay? So whether you went to pi or you went all the way back to 0, the tangent would again equal 0. Okay? Does that make sense? Pretty much? Kind of? Alright. Alright, what I want to do the remainder of the time is let you guys work in small groups, okay? You don't necessarily have to go in order, okay? But do work on some of these. Page 384, there's just a whole bunch there. Again, remember, homework is not required, but it kind of is, or else you won't do well on your test.
If you don't do it,
It's not graded, but it is kind of required, all
there's
right?
a non-positive outcome if you don't